Hello everyone, welcome to our engineering graphics lecture series. Friends, in this video we will solve another problem based on projection of straight line. And the problem statement is the point M of a line MN is in HP while its other end N is 50 mm above HP and 80 mm in front of VP. The line is inclined to VP at an angle of 30 degree. Draw the projections of a line if its elevation makes 29 degree with HP. Find the true length of the line and the inclinations made by the line with HP. So here the point M position is given. Point M, the point M of a line MN is in HP. Point M is in the HP while its other end N is 50 mm above HP. Point N is 50 mm above HP and 80 mm in front of VP. Same point N is 80 mm in front of VP at an angle, okay, in front of VP. The line is inclined to VP at an angle of 30 degree. So the line, true length of the line is inclined to VP at an angle of 30 degree. So phi angle is given here. Phi is 30 degree. Draw the projections of a line if its elevation makes 29 degree with HP, and we know that the elevation makes alpha angle with HP plane. So alpha is 29 degree is given. Find the true length of the line and inclination made by the line with HP. So first draw the reference diagram. This is x, y. Draw the locus of M dash, this locus of M dash, this is locus of M, this is M dash, M, theta, phi, locus of N dash, locus of N, true length, true length. This point is N1 dash, this point is N2. Project N1 dash up to locus of M, we'll get a plan lane. From M, this is a N1. From M, mark a arc up to locus of N and get a point N. So join MN. So this is a plan lane and this angle is a beta angle. From N, we can directly draw the vertical line. This is N dash, elevation lane. This angle is a alpha angle. Similarly, from N2, you can project it and then rotate it. Now see the problem, given data. Now here, point M is in the HP. Point M is in the HP, so we can directly mark point M dash on XY line. This is a XY line. So in this problem, for this problem, the XY and locus of M dash is same. N is 50 mm OHP. So point N is, this locus of N dash is 50 mm above HP. From XY, mark 50 mm distance and draw the locus of N dash. Draw the locus of N dash. This is a locus of N dash. Also point N is given. It is 80 mm in front of a P. So below XY, we can mark this locus of N at 80 mm. So adjust a ruler along XY and draw the line parallel to this XY. So we'll get a locus of N. Now here alpha angle is given. So we cannot mark a phi angle because M position is not given in the problem. So here first we can mark a phi angle. Phi we cannot mark, alpha we can mark easily. Alpha is nothing but a elevation length angle. So we have the M dash point. From M dash, mark 29 degree, 29 degree here. So draw a alpha angle line. So you can directly get a N dash point. This is a elevation lane, or it is also called as a front view. Now after that, we have the elevation lane. From elevation lane, if you mark a R and if you project this distance up to locus of N, we'll get a N2 point. So take a compass from N1 dash, mark a arc and project this point up to locus of n, will get a n2 point. Similarly, from this n, this is not n1 dash, this is a n dash directly. This is n dash, final front view point. Now from this n dash, draw the vertical line directly, because we know that n dash and n is on the same vertical line. Now you can see here, from this M we can mark a phi angle. So this angle phi is in between two parallel lines. So this angle phi and this also phi remain same. So we can mark phi angle from N2 point. Now take a protractor and mark a 5 degree angle from N2. It is at 30 degree. So before that, draw the vertical line which is passing through N dash. On this vertical line, we can find a M point position. So draw this 5 degree angle line. So here exactly we'll get a point M. So from M dash we can draw a locus line. This is a locus of M. Now here this is a true length, this is a true length, and the vertical projection line meets locus of N at a point N, join Mn, join Mn. So we'll get a plan length. So this is a phi angle, this is a beta angle. This angle is also a phi angle. Now in the top view, we can measure a two-lane distance, measure this two-lane distance, and from M dash mark a arc on a locus of N dash. We'll get a N1 dash point, join M dash and N1 dash. So this true length of the line is inclined with xy at a theta angle. Show the dimensions. This is 80 mm, this is 50 mm, 50 mm. Find the answers. True length, then elevation length, plan length, theta angle. So measure the true length distance. True length distance is 120 mm. Elevation length distance is 105. Then plan length distance is 120 mm. Find theta angle. Theta is 25 degree and beta is 32. So that's the complete solution for this problem.